Okay, this is worksheet practice 1-6, solving compound and absolute value inequalities. So I'm just going to pick some problems on here that we're going to work together, and so you can kind of check yourself. And I'm working on I'm writing on my tablet, so it's going to be really messy, but I can't really do anything about that. Okay, so let's work just number 5, make sure you know what you're doing, and then I'm going to pick some others. Okay, so hopefully I can get this to work. Number 5, -8 is less than or equal to 3y minus 20, this looks really weird, is less than 52. Okay, so this is a compound inequality, and we know this is an an and one, because this is this compound. We have two different inequalities. So we're going to do this just like we did all the others. I want to solve for y. So I'm going to get rid of this 20. But instead of just adding 20 to one side, like over here, we also have to do it over here. Okay, so I have -8 plus 20. My signs are different, so I subtract, and I have a positive 12. Is less than or equal to 3y. These cancel. And then I have is less than 52 plus 20. That's going to give me 72. So now if I want y by itself, I have to divide by 3. So now I have 4 is less than or equal to y is less than 72 divided by 3. So 72 divided by 3 is 24. Now, since this is an and compound inequality, okay, I'm supposed to graph this. All right, so my smallest number is 4. So I'm going to go by 8. Go by 4s. 4, 8, 12, 16, 20, 24. Okay, so now I'm going to graph this. I'm going to go to 4. 4 is a closed circle because it's also equal to. I'm going to go to 24. 24 is an open circle, and I want all the numbers in between. Okay? So that's number 5. Let's pick another one. Let's just go ahead and do number 6 and make sure you're doing it right. So let me see if I can get a new page. Whoops. Okay, let me stop this for a second. Okay, so this is number 6. I know it looks really bad, but that's the best I could do right now. All right, so number 6, I'm going to distribute this 3. So I have to say 3 times this and 3 times this. So 3 times 5x, 15x. 3 times -2 is -6, is less than 24. And then I'm going to go ahead and solve this. So I'm going to add 6 to both sides. 15x is less than 30. Divide by 15. So x is less than 2. Or, and I'm going to do the same thing over here. I have to get x on one side. So I'm going to bring my x's to the left. So I'm going to subtract 5x. And I have x minus 4 is greater than 4, because these cancel. So now I'm going to add 4. So x is greater than 8. So this is an OR problem, and OR problems are graphed by the union of their graphs. I'm just supposed to put the graphs of each one on the same line. So I'm going to start with 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to go to 2, circle it. It's an open circle, and then it's going to be pointing to the left. X is greater than 8 is an open circle, and it's going to be pointing to the right. So that's number 6. Okay. So let's do some with the absolute value bars. Let's do, we'll do 11 and 12. So number 11. Absolute value of x minus 8 is greater than or equal to 3. So first of all, we know when we have absolute value problems, we're going to have two problems that we're going to have to solve. So I have greater than. I have to figure out if greater than is an or problem or an and problem. Greater than, if you'll look back in your notes, greater than will always be or. Okay, so I'm going to write my two problems. Remember, when you write your problems down, you no longer have the absolute value bars around them. Or x minus 8 is less than or equal to negative 3. So I have to switch my inequality. So I'm going to add 8. X is greater than or equal to 11. Or add 8. X is less than or equal to 5. So now we're going to graph these. I'm going to start with 5, 6, 7, 8, 9, 10, 11. Whoops. So or problems, we just combine their graphs. So I have x is greater than or equal to 11. It's a closed circle this time. It's going to be pointing to the right because x is greater than. Or x is less than or equal to 5. All right. So now let's do number 12. Okay, number 12. Absolute value of 2z minus 3 is less, 2z minus 2. Is less than or equal to 3. Now, less than problems are connected with the word and. Okay, and there's two ways we can write this. We can write it as a compound inequality, or we can just write it as two problems connected with the word and. Okay, in my previous video, I wrote it as a compound inequality. I'm going to write it as two this time.